All right, so I wanted to do another example for you. This time we're going to use the halogen bromine. It's going to be a very similar process. And again, what we said was that the first thing we should be able to do is to predict all possible products. Okay, so what we're going to do is first we're going to just pretend like all of these carbons are completely independent of one another, right? As if they'll all give us different products. Sorry. And then I'll go through and look and make sure I didn't draw any duplicates. All right, so I got these different groups of carbons that are colored here. I'm just going to kind of go in order. Again, I'm using a different halogen, but it's the same idea. All right, we'll stick one on that middle red carbon. One on that blue carbon. And over here. Okay, so because I have 5 carbons, I could have a maximum of 5 different products in this reaction. But now I want to go through and make sure that I don't have any duplicates. Okay, so this is something that you can do sort of both visually based on the symmetry in the molecule, but also you can, again, like I said in class, you can always sort of convince yourself by naming the molecule. Okay, so just for the sake of time, I'm going to go kind of quickly here. We've been over nomenclature a bunch. This would be 1-bromo 2-methylbutane. I'm going to run out of room. I got to write smaller than that. All right. Here, the bromo and the methyl are both on carbon 2, so this would be 2-bromo 2-methylbutane. Remember, bromo is always going to come first because it's first in the alphabet. If I go here, this is actually one of the hard ones where I have this tie that I have to break between my numbering scheme. And I'm going to do it based on alphabetical order. So this is 2-bromo 3-methylbutane. And then lastly, this one would be 1-bromo 3-methyl butane. Okay, but now there's one that I left out here, all right? And so if I do this, I'm going to kind of do this the long way just to sort of make a point here. Okay, I can see people being tempted to say that this was our parent chain here. But this is not a substituent that we know how to name. And it's not a substituent. It contains both a carbon and that halogen group. I mean, maybe in theory you can come up with a molecule like that, but that's not anything that you'll ever see in this course. So instead, you need to pick your parent chain more carefully. We're going to pick these 1, 2, 3, 4 carbons here instead. So carbon 1, 2, 3, 4. So this would be 1-bromo 2-methylbutane. Let me put my original color back on here to make a point. Blue, red. Okay, so we have indeed, these are all distinct products. They all have distinct names, but we see that these two are identical. They share that same name. And it might be hard to see that these are identical by looking at them on pencil and paper. But remember, we can always rotate around these single bonds here. And if I did that, that would bring me to this structure. This is something that's a little bit easier to see if you have one of those chemistry model kits. Okay, so I'm not going to put them both down. I'm going to only put one. But what I'm also going to sort of make note of here is that means that this blue carbon up here is really part of that purple group. Both of these would give me my same product. So in terms of all my possible products, these are the 4 that I have here. So then the next step is to calculate. Really, it's like determine the major product, but to do that, we have to determine the percent composition or distribution of our products. You'll hear both of those words. All right. And we got to do so for each one. So I'm going to have a calculation. Oh, and let me just say, we're going to put these 2 in the same group. All right, cool. So I'm going to have a calculation for my purple group. I'm going to have a calculation for my orange group, calculation for my green group, and I must have missed one, my red group. All right, each one of those products I need. I guess to be clear, by purple, I mean when I added bromine to the purple carbon. My red group is this product here, the 2-bromo-2-methylbutane, when I added my bromine to the red carbon. Here's when I added the bromine to the orange carbon, and when I added my bromine to my green carbon. So I'll have 4 different groups, and for each one in our calculation, we need the number of hydrogens in that group times the reactivity factor of that group. So for this purple group, now that I had 2 carbons that would give me the same product, when I'm counting my number of hydrogens, I have to total up the total number of hydrogens in this purple group here. So that's 1, 2, 3, 4, 5, 6. So my number of hydrogens are 6, and they're all primary carbons. Well, they're the same group, right? So they have to be the same. They are primary carbons. So that's 6 times 1. If I do my red, where my bromine was added to my red carbon, here, there's already 3 bonds. So that means there's only 1 hydrogen on that red carbon. But for bromine, that reactivity factor is ridiculously high for those tertiary carbons, 1640. So I have 1 tertiary hydrogen times that 1640 reactivity factor. My orange, how many hydrogens rather? So this is a secondary carbon, so it has 2 hydrogens. And the reactivity factor for bromine for 2 hydrogens is 82. And then lastly, that green group. This green group is also a primary carbon, but I couldn't lump it in with that purple group because it doesn't give me the same product as the purple group. So this would only have 3 hydrogens and that reactivity factor of 1. Okay? And I'm going to take these all and I'm going to divide it by the sum of all of these numbers together. I'm going to be lazy and just write this sum signal and then multiply by 100 to give me a percent. Okay, I guess I should have a calculator. So my sum is 1813. So I'm just going to replace my sum here by the sum of all those values, the 1813. All right, so 6 divided by that times 100 This gives me 0.3%. I think we can see without doing the math what our major product is, but let's just go for it. This would be 90.5%. This one is 9.0%. And then finally the 3, my very distant fourth, 0.2% for this one. Okay, so my major product in this case will be that 2-bromo. And we can see that this is the case in large part because of these reactivity factors, because my reactivity factor for a tertiary carbon is so much higher. But that's not necessarily always going to be the case. For bromine, it is more often than not because of how high that reactivity factor is. But it's not always the case for chlorine because, of course, we have that other part of this equation too, the number of hydrogens. Okay, so that's why we can't just look at the chart. We got to do the math.